Okay, so I know that my last couple videos have been kind of quiet, so I'm just going to try and talk louder this time. Welcome to Unit 2, Motion. We're going to be talking about a couple things in this video. The idea of origin, position, velocity, the velocity triangle, and the parts of a line graph. Okay, so why do we need to study motion at all? Well, the reason is because it's kind of an idea that's important that you can build off of to learn about things like force and energy. And we're also going to be talking a lot about graphing in this unit, and so we're talking about graphing and then a little bit about the power of exponential growth. So where to begin? Well, let's begin at the beginning, known as the origin. No, not this origin. The other origin, the origin at the middle of a graph, right? You probably know this from math class whenever you're using a grid system, the 0, 0, the point right at the beginning, that's the origin. But in science, we have a different definition, and we call the origin wherever you begin measuring from. So whether that's like a race or whatever that is, the origin is wherever you begin to measure from. Okay? Yep, kind of like the panda origin was at the top of the hill. Okay, position. So position is the most basic idea of movement, and so it's just pretty much the location. So it's the location of something with reference to origin. So for example, on this graph, you see that at time 0, the position is 0 at the origin, right? At 1 second, the position is 10 meters. At 2 seconds, the position is 20 meters, so on and so forth. So it's just a location, right? Pretty, yeah. All right, now we're going to a little bit more complicated of an idea, and we'll be doing a lot of practice with this idea of velocity. So assuming we can kind of get the idea that position is just related to, where you are, velocity is more complicated. So some examples of velocity is like in your car, kilometers per hour, right? That's a measurement of velocity. Okay, and usually it's measured in meters per second, but it could be kilometers per second, meters per hour, gigameters per nanoseconds, whatever, you know the units, but that's how it's measured. And we're going to be practicing uh, with the equation of velocity, right? And velocity is related to position and time, right? And so you solve for velocity by dividing your position by your time. So let's say you go 10 meters in 1 seconds, position 10 meters divided by time, 1 second, 10 meters per second, right? 10 meters per 1 second, right? So you go 20 meters in 2 seconds, 20 divided by 2 is still 10 meters per second. So you're going 20 meters in 2 seconds, right? And it makes sense, and you get this nice straight line, and that means that the velocity is always 10 meters per second on this graph. Okay, so that's how you solve for velocity, position divided by time. And so here's another example. I run 5 meters in 1 second. So your velocity is 5 meters, your position is 5 meters, your time is 1 second, 5 meters per second. Okay, and so what I'm going to be challenging you guys to be able to do is to not just calculate velocity, but to also be able to calculate position from velocity and time from position and velocity. So, if I give you, all right, you're running at 5 meters per second for 1 second, I want you to be able to tell me that your position is now 5 meters away from wherever you began measuring. Or the velocity is 5 meters per second and you move 5 meters, how long have you been running for? Well, for 1 meter, right? And so I want to show you how to do that, to do those calculations mathematically. And that's what we'll practice on Monday, okay? And so here's a good way to kind of cheat, or not cheat, but like if you have a hard time with this equation, one way that you can use this is, let's say I give you velocity. Well, let's just start with velocity, right? I'm trying to solve for velocity, so I cover up velocity. You can't see velocity. And then what I do is I take position divided by time, right? Let's say I give you a problem where I ask for position, right? I cover this up right here, and then I get velocity times time. Okay, so if I'm asking for what time, I'm going to take position divided by velocity. So I know maybe that's a lot of words. Yeah, I'm going to give you an example and we'll talk more about this on Monday. All right, so let's say I'm going 5 meters per second and I go that fast for 5 seconds. I want to figure out the position. So I'm given velocity and time. I'm given velocity and time. Okay? You see, in order to get velocity and time, I need to multiply them together to get position. Okay, so we've got position equals 5 meters per second times 5 seconds. And that gives you a position of 25 meters. Okay, so some of you might be able to do this in your head. Some of you might want to use the triangle, but either way works, and whatever is good for you is good. Okay, so we're going to be talking about line graphs. We've done a little bit about bar graphs, and my goal is for you guys to be able to tell the difference between when you're supposed to use a line graph and when you're supposed to use a bar graph. Okay, so line graphs are used when data is connected to the rest of the data. So that's kind of a confusing idea, but for right now, you use a line graph whenever time is involved. So if there's time, use a line graph. If not, most of the time you're going to use a bar graph in my class or another way to represent the data, okay? So if time is involved, then that probably means that you're going to be wanting a line graph, and if not, then don't. Okay? I mean, the goal is what I want you to think about. I want you to see the data and think, what is the best way to present this? And then see that, okay, yeah, if it's time, then it's definitely a line graph. And remember, time always goes on the x-axis. All right? So your homework is you need to fill out your graphic organizer. I will be grading this, so do it. Hopefully you watch this whole video and you're not going to be like, oh, no, I didn't have it. Anyways, I hope you have a nice weekend, and that's all for today.